Okay, I believe we're live. Let's just check. Yes, we are, and the audio seems to be working, which is excellent. So, welcome back, everybody. Great news, over the weekend, even though I know I made a video Sunday, but over the weekend we passed 200 subscribers, which honestly, not like a massive milestone considering that there are channels out there with millions. But it's awesome for me. It's great. I've been having a blast making like Golang tutorials, and I figured today we'll take a break from like the heavy, complicated stuff that we're covering in the NNFS videos, which you could see on my channel. There won't be a link in the description, but go find the playlist or whatever and check it out and see if it's something you're interested in. Today I'm going to walk you through making a cool fireworks simulation in Golang, which is super fun. I've done it before in Python, but I'm doing it in Golang now with you in celebration because fireworks, yay! Fireworks are a great way to celebrate. So let's take a look at what we're going to be doing today. Here I have the completed code over here that we're going to be covering today. And let's just first take a look-see at what we'll be making. So pretty not assuming window over here in Golang, and if you click somewhere, it makes a firework that has sound in it as well, I think. Hopefully it's coming through. Let's just see if the sound is coming through on the stream. It is. There may be some echo because the sound is coming out of my computer and it might go back into the microphone. But anyway, if you click anywhere, and as you can see, there are several different sounds. The white fireworks have a chance of showing up as rainbows, and also you could turn on the firework display by hitting the spacebar. And that's just chaos. We're gonna turn that off. Anyway, super cool. So let's get into the coding. So I'm going to close this, and I'm going to open a new folder. You could open this folder or create this folder really wherever you want. I'm going to go into my tutorials tab, and then I'm doing fireworks simulation, and I'm going to make a new folder. I'm going to call this simply code because this is where I'm putting the code, but you probably want to call this like fireworks simulation or firework display or whatever you want to call it, but I'm going to call it code, and I'm going to select the folder, and great, we will be put into this brand new project. So by the way, prerequisites, or however you say it, you need to know how to Golang, and you need to know how to Golang. You need to know how to code in Golang, because I'm not covering that. So there'll be a link down below to where you could see a nice tutorial from someone else, excellent tutorial to take you through Golang. And the graphics library we're going to be using is one called Raylib. So you're probably going to want to get that if you don't already have it. There'll be a link in the description to where you can get that, the Go package link. To download the Raylib thing, to download the Raylib library, there'll be documentation there on how to install it and how to get it working. So once you have that and everything is set up, you can make a new file. I'll call this main.go. And this will be our main file, obviously. So let's just give it the appropriate name, package main, and then we'll make the main function, func main. Let's just get into the coding, fmt.println. Hello. And let's make a new terminal. Let's run this, go run everything. This is just a good habit to get into, making sure that everything is working. Hello, excellent. Okay, so everything is working. I'm gonna leave this line of code actually here because I like having the FMT package, at least in my main file. And it's kind of a bad habit, but whatever, I like it. So the next thing we're gonna do is actually we're gonna leave the main file instantly and we're gonna make a new file. We're gonna call this file game.go. And this will be where our game management struct is located. And we're going to call that game actually, package main, and then we're going to say type. We're going to make a new type. We're going to call it a game. We're making game struct, and this will be a struct. So what does the game need to have? Well, simply in the beginning, all the game really needs to know. All the game really needs to. In the beginning, the game really doesn't need to know anything. So let's just close that, and let's make a func. We're going to call this, first of all, it's going to be g star game, because it's going to be a game function. And we're going to call this init. This will be how we initialize our game. All that's going to go over here is we're simply going to do rl.init. Oh, rl, we need to import Raylib. So I'm going to say import and rl. And you need to go into your, if you're not familiar on how to import things in Golang, you have to go into your Go script folder, which will be located wherever your Go folder is. Whenever you install Go, it's going to prompt you to make a Go folder. It'll probably be in your main users' documents, but wherever you put it, we're going to have to go to the Go folder, source, github.com, Gen2Brain, Raylib. This is just like the path for the Raylib library, and then Raylib. Great, so this is the path. We need to copy everything from github.com until Raylib. Then I have to switch out these backward slashes for forward slashes. There you go. So this should be Raylib. Excellent. And now we say rl.init window, because we're initializing the window, with a width and a height and a title. So to get the width and height and title, we're going to make a new file. We're going to call this settings.go. This will be where we put a bunch of no, not package code, but package main. This will be where we put a bunch of constants and stuff for our game. So const. We're gonna make a whole bunch of constants at some point, but for now it's gonna. Oh boy! For now it's only gonna be 2. The width, which is going to equal, let's say, 1,000. Nice big screen. The height, which will equal, let's say, 800, and a title, which will be, quote, Fireworks display. Great. And now when we initialize our window, we will say with a width of width and a height of height and a title of title. Great. Excellent. Now after initting the window, we should make another function, which will be g*game. And this will be the opposite of init. This will be close. And in this function, we'll do rl.close window. Great. All right. Now in the, oh, and this should be capitalized. Okay. Now in the main file, whatever. Okay. In the main file, we're going to make a game, which will be of type game. It's going to be a game struct. And we'll simply say game.init and defer game.close. Excellent. Now let's run this, and we should see a little window pop up for a split second. Yep, we got a window popping up for a split second, but it's not doing anything because we don't yet have the game loop running. So in order to make the game loop, we actually have to do a whole lot of things at once, otherwise it won't work. So the first thing we need to do is the game needs to keep track of whether or not we are currently running the game. So running will be a value in the game struct, and we'll call this bool. Not call it, it will be a bool. And let's make a new function, func g*game. We'll call this function loop. The way any game works is you have a game loop, and in the game loop, the first thing you do is check for user input, then you update everything in the game, and then you draw everything. So we're gonna build the skeleton of that right now. So this is our game loop, and we're gonna say for g.running as long as we are running the game. The first thing we should do is we should see if the user hits the little X button. And in Raylib, the way we do that is we do if rl.window should close. This returns true when we hit the little red X button on the window. If that happens, then g.running equals false, and we should return out of this running function, this looping function. Otherwise, if the user has not yet quit, we should do g.update. The game should update, which will be a function that will code, and we'll do g.draw, which will also be a function that will code. Okay. So now let's make the update function, func g*game update. Actually, I don't know if, should I make this bigger? No, that's way too big. I think this is plenty big. Let's see in the video. You guys can see this. It's okay. Yeah, maybe I'll make it bigger. Sure, why not? Yeah, why not? I'll make it bigger. No, I think it was fine the way it was before, actually. Never mind. Okay. Is this how I normally code? Yeah, this is how I normally code, I think. I remember that it needs to be like 1 bigger than how I normally code. I don't know. Let's just see. You know, yeah, I think I will make it. I think I will make it like this. Sorry. Okay. So in the update function, we're not going to do anything for now, because there's nothing to update yet. So we're just going to leave that blank. And now let's make the draw function. The draw function is important because in order for the window to not break, we have to at least be updating it with something. Otherwise, the window will sort of just freeze. So to draw, we should just do, to draw in Raylib, you do rl.begin drawing. And then we defer rl.end drawing. And then we could say rl.clear background, and the clearing background wants a color. So let's make a background color in our constants file. We can say bg color equals rl dot, let's say black. And this, I forgot a bunch of syntax. Var bg color, which will be a type rl.color, equals rl.black. Excellent. And this will automatically import the rl thing. In Visual Studio Code, at least, you might have to import it manually. But anyway. rl.clear background with our new bg color. Excellent. And right, this should be capital. The loop should be capitalized because we're going to call it outside. What's wrong with you? Bool is set to, okay, and also we should init running as true. So g.running equals true. That will do that in the init function. And then what else do we need to do? Oh, right, yes. In the init function, we have to do rl.setTargetFPS. We have to tell it how much FPS it should be trying to do. And to do this, let's make another constant, which we'll call FPS, which will equal 60. And we'll pass it in over here, FPS. Excellent. Now we will call the game loop function. So we'll come back to the main.py, and we'll do game.loop. Excellent. Run that. And we should be getting a straight up window that is black and will end if we click the X button. Excellent, which is what we programmed in over here. Great. Now we should start working with the update function. We should start getting user input to see if we want to launch a Firework, basically. So let's come over here and we'll say if rl.is mouse button pressed. This gets detect if the mouse button has been pressed once exactly. And which mouse button? We want to do rl.mouse left button. We want to check the left button. Then we'll say fmt, oh boy, fmt.println launch. This is just to make sure that we're getting the user input. So let's run that. And let's click. Launch. Great. Okay, so we are launching. Now instead, we want to actually make a firework. So let's first of all make a comment. Create new firework. Okay, so to do this, we'll actually, we're going to make a new file. And we'll call this file fire, I'll make the, firework.go. This will be package main, and this will be a new struct, and we'll call this firework. So type firework struct. Okay, now what will every firework have? Well, every firework will have an X position, so it'll have a pos X. It'll have a Y position, so pos Y. It'll have a velocity. Okay, so these will all be int 32s. It will also have a radius, which for Raylib, the radius is going to need to be a float 32, I believe. So float 32. I believe it's a float 32. Let's actually just check. rl.draw. No, I can't do it over here. Here, func. Blah. I'm just testing to see. I need to get some documentation. rl.draw circle. Because we're going to represent our fireworks as a circle, and the radius needs to be a float 32. Great. So great. All right. So the radius of the firework will be of type float 32. It will also have a color, obviously, color, which will be of type rl.color, rl.color. And then the firework needs to have an X, a Y, a radius, a color. Yep, I think that's it, at least for now. So let's come over here. We'll make func new firework. This will be a function that returns a new firework. So it will return a firework. And we'll say f colon equal. Actually, we don't even need to say this. We just need to return firework. The x will change between each firework, so this function should expect an x, which will be of type int32. The velocity will change between each one, so it should also expect a velocity, which will also be of type int32. The y position won't change. The initial y position will always be a little bit below the screen. The r value will change, probably. Will it change? Nah, the r value probably won't change. Or at least it won't change in any way that we need to get data from the outside. Actually, I don't think any part of this will change in any way that we need to get data from the outside other than the x value. Yes, I think that's true. So all this really needs is an int32 for the x. And we'll say that the fireworks x is an x. And we're gonna need to do some more stuff, I believe. Wait, what's wrong here? Unknown field x instruct literal. Oh, pause x. Call it pause x. Okay, and then, so let's start generating the pause y and the velocity and the rate. Okay, so pause y will be quite simple. Pause y colon equals height plus 10. It'll be like all the way down the screen plus a little bit more, just to get a little bit below the screen. The velocity will be randomized at some point, but for now let's just say that the velocity will be like, I don't know, we want the velocity to be a function of the height of the screen. Like the taller the screen is, the more velocity it will have to reach the top of the screen. So let's just for now say that the velocity is going to be height times 1 over 20. Like a certain part, because we don't want the velocity to be the height of the screen. If the velocity is the height of the screen, it will shoot up to the height of the screen in the first frame. We want the velocity to be, well, if we're going at 60 frames per second, that means that in 1 second it'll be 60. We have to think about gravity, because gravity is going to be pulling the firework down. So we'll think about this kind of stuff later. But for now, the velocity will simply be the height times 1 over 20, so that the firework shoots up into the air. And this actually needs to be a negative, because negative values are up in Raylib, so negative of that. So that's the pause y. Velocity, radius for now we'll just say is going to be like 3, I don't know. And the color for now, let's just say that the color is going to be rl.red. Okay, now let's say, okay, pause y is going to be pause y, and velocity is going to be velocity. It's funny, it's making it 32s of this stuff. This will never change. I don't think we're ever going to make the position y random, so that could go in there. But the velocity will be random at some point, so we should keep that as a variable that we generate. The radius will be r. I don't think that we're going to ever make that random either, but just for now. And also this should be float 32. So here, var r type float 32 equals 3. And then we'll say that the color will be just simply color. Okay, just to make sure that all of this is working, over here we'll say that f colon equals a new firework, and this needs the x position. So what should the x position be? Well, it should be the mouse's x position. When we click on the screen, we want the fireworks x position to be the mouse's x position. So let's go rl dot mouse x, get mouse x, rl dot get mouse x, and then I'll do fmt dot print ln of f just to see if this is working. So let's run that. Okay, and as you can see, we are generating a firework struct with these values, and you see that the x value changes, but everything else is pretty much the same. Okay. Now, what's the point in having f if we could never use f? So let's actually set up a way to keep track of all the fireworks we create. So the game struct should have a list of fireworks. Let's call this fireworks. And this will be of type, it's going to be a list of fireworks. And then in the init function, we should do g.fireworks equals make and it will have a length of 0. Make a list of fireworks with a length of 0 to start with. I don't know if this matters, like doing this line as opposed to just this line, but I think it does. So let's just move on. And then we could come over here and we could say, instead of f colon equals new firework, we could simply say that g dot fireworks equals append to g append to g dot fireworks a new firework. Great. No, not great. What's wrong? Awesome. Okay, so g dot fireworks equals append to g dot fireworks a new firework. We still won't be able to see it though, so we have to make a function for seeing it, func. And this will be f, not star fireworks, because this won't actually change the firework in any way, so we'll just call this f firework. And we'll call this show. We don't need to put the star there, the asterisk by firework, because we're not actually modifying f in any way in the show function. In the show function, we don't actually modify it. So we'll do rl.draw circle. The x will be f.pause x. The y will be f.pause y. The radius will be f.r. The color will be f.color. Excellent. And now, this needs to be capitalized. And now in the game, we'll do, after we clear the background, we'll say for I colon equals range of g dot fireworks, g dot fireworks indexed I dot show. Excellent. Now, if we run this, we still won't actually see anything because all the fireworks will be below the screen, which is not convenient. That's just, so I'm clicking, but no fireworks are showing up because they're all below the screen. So we have to make a new function for updating the fireworks so that the position actually flies up using the velocity. So we'll say func f, and this time we're willing to be a star firework because we are modifying it. Update. We're updating the firework, and we are going to say very simply that f dot pause y plus equals f dot velocity. That's just simple, physics. And yeah, I think that's it. I think that's all the update function needs to do. So there you go. And then we're actually going to have to call the update function using a similar for loop. So let's copy this for loop from down here, and then we'll say g.fireworks index I.update instead. All right, so let's run this, and you should see they're all red though. That's a little bit annoying, and they're all just flying off into infinity. So those are a few problems that we're going to have to fix, I guess. The fact that they fly off into infinity, and the fact that they're all red. So let's fix the color problem first, because I don't like seeing a bunch of colors. So let's make a list of possible colors in our settings.go file. So let's say var firework colors equals a list. Oh, and I also have to tell the type of what this is. So there's going to be a list of rl.colors. Okay, and this is going to equal a list of rl.color. And what are the colors going to be? So let's just start off rl.white. There you go. That's one color. And let's do rl.red. That's another color. And let's do rl.green. No, not gray. Green. And let's do rl.blue. Okay, there you go. Those are the main colors. Now let's see if RL has anything else. I think I saw a lime there. Yeah, rl.lime. Let's do rl.yellow. I'm sure Raylib has a yellow. Let's do rl. I don't know. Does pink? Yeah, it's got a pink. Great. rl.purple. You got a purple? Yep, you got a purple. Excellent. rl. I don't know. What random things do they probably have? They have a gold. Let's do a gold. rl. Anything else? Maroon. We could do a maroon. Do you have a magenta? rl.magenta. You have a magenta. Excellent. rl. We're just getting all the colors, and we're just going to put this in the violet. I like violets. Maybe sky blue. I saw sky blue over there. rl.sky blue. Let's do rl. Think, was that it? Did we finish it all off? Yeah, we have a yellow. Okay. There you go. So there you go. Here we have a nice list of possible colors. And all we have to do is, in the firework, instead of just setting the color to red, we can set the color to a random color. But to do random, first we have to go to the main file. We have to import random. So let's make this import statement a little bit more intense. let's import math/rand. Okay, and then the first thing we have to do is we have to do rand.seed. We have to set the random seed. So what value should we pass in? Well, let's also get time. And we'll pass in time.now .unix, and there you go. That will get you like a random number to initialize our pseudo-random generator. Great. Now that we can get random stuff, let's go back to Firework. And we also have to import random over here. So let's do quote math/rand. Once the random seed is initialized in our project, we don't have to initialize it again. So we'll come over here, and color will equal Firework colors index. Which one of them should we do? Well, let's do a random one. So we'll do rand.int31n from between 0 to what value? To the length of Firework colors. There you go. And now this will give us a random Firework color. What's the problem here? It's returning an int. So, and this thing wants an int32. So let's just int32. We'll just cast this to an int32. What's the problem here? Yeah, there you go. I capitalized the I when I shouldn't have. Okay, this will get us random colors. So let's check this out. Let's see if this works. All right, that was a pink one right there. Boom, the red one just flew through. Okay, yellow, bunch of stuff. The radius is a little bit small, I have to say. Let's increase this to 5. Let's try again. Okay, pretty good. I like it. I kind of preferred it when it was smaller. So let's do a 4. Happy middle between the two. Okay, fine, good enough. So you see how it's all random, but as you can see, they're still flying off into infinity. So let's change that. We have to have gravity. So let's go back into settings, and we're going to make a constant, gravity, which will equal, gravity will be, it's going to be a positive value because we're going down, which is positive values in the y direction. So let's just say gravity is 1 for now. And then in the Firework, by the update, before we add the velocity to position, we'll do f.velocity plus equals gravity. So we're going to modify velocity by gravity, which is an acceleration. This is just basic physics stuff, but simplified into code. In fact, what we could even do, if we wanted, we could pick a point on our screen, and we could say we want the Firework to reach this point, calculate the velocity it needs to have based on the fact that you have gravity. That might be a cool way to code it. If you want to do that, you can. For now, we're gonna just guess velocities. So there you go. So now you see the Fireworks are coming up and they're falling. But as you can see, they're also falling down to infinity. So now we have to create a system for the Firework to explode. Yeah. So the way I did it in my code was a little bit efficient. It was very efficient, but it was not very readable. So let's make a new function. Func f star Firework. Actually, we don't even need the star. We just need Firework. We need the data. And this one, we'll call this should explode. Should the Firework explode? And this will return f.velocity, whether or not the velocity is greater than or equal to, let's just say 3. If the velocity is greater than or equal to 3, what's wrong? Oh, I didn't say that it should return a boolean. If the velocity is greater than or equal to 3, then we should return true. In other words, it should explode. So now in the game, we could see in our loop where we're updating, we can actually type in fmt.println g.fireworks should explode. g.fireworks index I should explode. Should our Firework explode? And we'll see that when we launch a Firework, false, 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 true, 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 true. So when it starts falling, that means that it's time for it to blow up. Okay, so let's actually program in the blowing up of it. So we'll get rid of the FMT statement, and we'll just say if the Firework should explode. For now, all we'll do is just remove the Firework from our Fireworks slice. So the way to remove an object from a slice, well, first of all, you're going to have to iterate through the slice backwards. So let's change this for loop a little bit. We'll say for I equals the length of g.fireworks minus 1, because we're starting at the next value, the last and next value. as long as the I is greater than or equal to 0. If it's equal to 0, we still want to do stuff. I minus minus. So now we're iterating through it backwards, which is the same thing. The only reason why we want to iterate through it backwards is that when you're doing a loop that may involve you removing elements from a slice or a list or what have you, you need to iterate through it backwards. Otherwise, you're going to mess yourself up. You're going to end up skipping over values. You could write it down on a paper what the loop will be doing, and you'll actually see that it will skip certain values unless you iterate through it backwards. So what we'll do is we'll swap this firework to remove an item from a list in Golang. The best way to do it, if you don't care about the order of the slice or the list or what have you, you want to say that g.fireworks index the length of index I, g.fireworks at the I at the position we're currently looking at equals g.fireworks dot last. Yeah, this is a cool Visual Studio Code syntax. You could say g.fireworks index length of g.fireworks minus 1. So we're basically taking the last element in our fireworks list and we're just moving it over to the one that we're currently looking at, the one that we want to remove, the one that we want to explode. And then we'll say g.fireworks equals g.fireworks of every single value in g.fireworks until the last one, till the length of g.fireworks minus 1. I think this is the syntax for removing things from a slice in Golang, I believe. What is this doing? Well, let me write this out because this is a little bit complicated for someone who hasn't seen it before. Let's make Notepad. Okay. Imagine you have a slice 4, 3, 2, 1, and imagine we want to remove 3. Well, the first thing that we could do is we could say to move the 1 to where the 3 is. So we'll have 4, 1, 2, 1, because we didn't actually move the 3 back to where the 1 is. And then what we can do is we can say that the slice should be everything in the slice up until the last value. So that would be 4, 1, 2. And this only works if you don't care about the order of the slice, which we don't really. We don't care about the order of the slice. It's just about how many fireworks there are and keeping track of them all at once. And this way, as you can see, we end up with the exact same slice, except the 3 is gone, which we wanted to do, and also the 1 is where the 3 is, which is just a quirky little coincidence. It's not a coincidence, we made it that way, but anyway, I believe this is the syntax. Everything up until the length of the fireworks minus 1. Let's check it out. Let's just see. Okay, it's gone. Yeah, it's gone. Yeah, they're gone. All right, let's put 2 in. Yeah, and they fall. Yeah, they both. Yeah, this is working. Yep, you see them all being removed. One thing is I want to feel like the fireworks have a little bit more mass, so I'm going to change this value from being greater than or equal to 3. Not mass, but I want them to like fall for a second before they explode. Just so that you get that feeling of like, oh, yeah, okay, I like that. Yeah, this is working, I think. Yeah, okay. Okay, excellent. So now, when the firework explodes, we need to generate all the little particles, all the little like little whatever they're called. So to do that, we're actually going to make a new struct, and we're going to call this particle, particle.go, and package main type particle. Oh boy, particle struct. Excellent. What will a particle have? A particle will have a pos x and a pos y. And it will have a velocity x and a velocity y, because the particle is going to fly out into, like, all the different particles will have x values and y values and what have you. So pos y, pos x, pos y, vel x, and vel y. And all of this will be, I don't know, like an N32 or whatever. Okay, and then every particle will also have a radius, which again needs to be a float 32, and it will also have a color, which will be the type rl.color. All right, that's all we need for now. We're going to need some other stuff, but that's all we need for now. And we'll say, yeah, we'll say, I don't know, new, func, new particle. And this one will take in, it needs an x, it needs a y, it needs it needs a speed. This is gonna need to be given a speed. Every particle is gonna need to know like how fast it should be going. So it needs a speed, and it doesn't really need a radius. It needs a color because I want the particle to inherit the color of the firework that blew up. So it needs a color. And now the x, the y, and the speed will all be in 32s. Speed doesn't need to be capitalized. What's wrong with you, x? Why are you upset? Oh yeah, and the color needs to be of type rl.color. Great. So now that we have all of that, we can say, and this is going to return, the function is going to return a particle. We can say that we should return a particle where the pos x is, no, not the pos y, the pos x is going to be the x, the pos y is going to be the y, oh, this is not pos x, this is, I misspelled it, it's supposed to be pos x in there. The color will be color, the radius, I don't know, like the radius will be like, I don't know, 1. And right, and now we need the velocity x and the velocity y. So the velocity x and the velocity y is going to be a little bit of a weird thing, because we kind of want it to be random in like a circle around the center of where the firework blew up. So the x and the y will start off as being the center where the firework blew up. And then what we want to do is we want to get a random angle that okay, I'll draw this out. Paint. The firework is going to fly into the air. Not the particle, the firework. The firework's going to fly into the air, and we're going to have, let's just make a circle to visualize the firework. Or do they have like an explosion? Yeah, they have like an explosion. So this is our firework. That's our firework, and it's exploding. And so every single little particle, it should also be red by the way, will be exploding outward. Oh, sorry, I want this to be a marker. Will be exploding outward in like a circle around it, right? Imagine that's a perfect circle. So you see how for a given particle, let's say this one, we can make a right triangle, and so the velocity in the x direction is going to be a certain angle times the speed, and the velocity in the y direction will be a certain angle times the speed as well, because imagine the hypotenuse is the speed. This is the speed, the hypotenuse, that is. So what we want to do really is we want to generate a random angle to use. And if this is not making sense to you, follow along in the code. If you know trigonometry, this should be making sense to you at least in some way. So let's get an angle. Angle colon equals rand. This needs to be a random angle. And again, it's random. The Visual Studio Code is automatically importing random and Raylib for me. If it's not doing that for you, you have to do it manually. Rand dot float 32. Let's make it a float 32. And then this will be, right, so this is going to be in the range of 0 and 1. And what we want to do is we want to get the angle in radians. So if this thing is giving us a 1, we want it to be 2 pi. We want to just change that into 2 pi. So a 1 is 2 pi. If it's 0, we want it to be 0. And if it's in the middle, we want it to map it to the middle. So the way we do that is we multiply this value by 2 times math. And now we have to import math. Just your normal math. Math dot pi. This way, this is a great way to get a random angle. You get a random float between 0 and 1, and then you multiply that by 2 pi, and that gives you just a random angle in radians. And now what we want to do is we want to say that the velocity in the x direction colon equals math dot cosine of the angle. Oh, so you know what? Instead of getting a float 32, let's get a float 64. Because cosine is expecting a float 64. And then we could say that that velocity y colon equals math dot sine of the angle. And we don't just want, because math dot cosine and math dot sine will give us values between 0 and 1. We don't want that. We want to multiply that by the speed that we're given. So let's multiply this by speed. Speed times math dot cosine, and then you know what? Fine. No, it's mismatched types. So let's do speed times. And what type is this final thing going to need to be? Well, it's going to need to be an int32. So let's cast math that sine and math that cosine to int32s. And there you go. And then over here, finally, we could say that the particles val x will be val x, and the particles val y will be val y. I'm going to turn on the air conditioning. Give me a second. Okay, now that we have the basic things to get these particles, what we should do is we should make a function for drawing the particles. Or should we do this first, or should we get a system in the game class for storing particles? Let's get a system in the game class for storing particles. So over here, in the game, not class, but struct, sorry, coming from Python. In the game struct, we'll say particles will be a slice of particle. And then, just as we did with the fireworks, we'll do g.particles equals make a slice of particle with a length of 0. Now, finally, in the I'm sorry if you could hear the air conditioning. The air conditioning is a little bit broken, so it's making noises. But in the place where we blow up a firework, if it needs to be blown up, we should say that new particles colon equals actually, you know what, before, we should really do this before we remove the firework. Yeah, because once we remove the firework, it's gone. So new particles colon equals g dot fireworks index I dot get particles. And this is going to be a function that we need to create. So in the firework struct, let's make a new function. Func f star firework, and this will be get particles. So this will generate a, I guess this will generate a, yeah, this will generate a slice of particles for us. So new particles colon equals make a list of particles, a slice of particles, with a size. That's a very good question. So let's actually make, in the firework struct, let's make it so that every firework knows how many particles it will have. So let's make a new value, particle amount. This will be of type int32. And then whenever we make a new firework, we'll say particle amount, particle amount colon equals a random value. Again, we need to import random, or maybe we don't, I'm not sure. A random value, so a rand dot, yeah, int31n. Between 0 and, what should we do? Between 0 and, let's say, 20. So the maximum will be 20 and the minimum will be 0, but I don't want it to be 0 as the minimum. I want it to be, let's say you can have, what's the minimum? 50 will be the minimum, and the max, you know, let's just do it between 0 and 50, and we'll add 50 to it, so that the minimum will be 50 and the maximum will be 50 plus 50, which will be 100. So you could theoretically spawn 100 particles. Okay, and then when we're making the particle, we will say this will be what will the size of our new particles slice be? It will be the size. So we need to actually pass this in. Sorry. When we're making the firework, particle amount equals particle amount, and then we'll use the particle amount over here. So f dot particle amount. Great. Now we have to populate new particles. So for I colon equals range new particles. New particles index I equals a new particle, and this needs an x, so the x value will be f dot x. The y value, the x value will be f dot pos x. The y value will be f dot pos y. The speed will be f dot. What will the speed be? So let's make this. Let's also make this a value in the firework struct. We'll say, sorry, particle speed. It's going to be of type int32. int32. And over here, particle speed. We'll start off particle speed as random. So particle. Same thing that we did with particle amount. Particle speed colon equals rand dot int 31 between 0 and, let's say, I don't know, 10 plus 10. So the minimum could be 10 and the maximum will be 20. What's wrong here? Oh, int 31n. Great. And then over here, particle speed will be particle speed. Nope, not speed. There you go. And then when we're passing in the speed, we can say f dot particle speed. And the color will be f dot color. Okay, now we return new particles. Great. And in the game, back in the game, new particles colon equals this, we should say that g dot particles equals append to g dot particles all the new particles dot dot dot. So new particles dot dot dot, all like expanding out that slice forward. Okay, now the problem is the obvious problem. If we run this, there's actually no difference. Why not? Because we're not actually drawing the particles or moving them or updating them in any way. So let's go back to our particle struct and let's make those functions. So let's make the function for the updating. We'll call this p star particle, and we'll call this update. And this needs to be capitalized. Update. All that will happen in the update function is we'll say that the p.posX plus equals p.velX and p.posY plus equals p.velY. Excellent. And that's it for the update function. Then we'll say func p particle show to show the particle. We will, and the s also needs to be capitalized over here. We'll say rl dot draw circle at the p dot pos x, p dot pos y, sorry, p dot r, the radius, and then p dot color. Great. Now, back in the game struct, we actually have, so just like we updated all the fireworks, we need to update all the particles. So let's actually copy this for loop for sorry, I noticed that I was not copying the brackets properly. Let's copy this entire for loop for updating the fireworks. Actually, we don't even do this. Let's just do it by hand. For I colon equals we're gonna have to remove the particles too. At some point, we want to remove the particles from this list. So let's think ahead and let's do the length of g dot particles -1, just like we did with the fireworks. I is greater than or equal to 0. I minus minus. We'll say g dot particles index I dot update. Excellent. And then very similar over here, we could actually copy this one. For I colon equals g dot particles index I dot show. Okay, let's run this. And you'll see that when the firework blows up, it actually blows up, but it's a little spot and nothing's moving, which is weird. I wonder why the particles aren't moving. G dot particles index I dot update. No, this is the fireworks struct. I don't know why I'm here. G dot particles index I dot update p dot pos x plus equals p dot vel x p dot okay, and let's check out the vel x and the vel y. Speed times int32 of because when we're turning this into an int32, this is wrong. Yeah, because no. We have to make this actually into a float 64. When we turn any float that's below 0 into an integer, it just becomes 0. And so that's just how integering works. All the integering system does. So this now needs to be a float 32. all that casting to an integer does is cut off the decimal. But in the math.cosine and the math.sine, we need the decimal values because that's all that we really have. Otherwise, it's just going to evaluate to 0, so we can't just cast those to ints. So we're going to have to do it this way. Great, and now let's run this again. Wow. That is absolutely beautiful. Okay, so a few problems. First of all, as you can see, they explode in a circle, which is not ideal. Second of all, the speed is way too intense. The speed is way too high. So let's take things one at a time. So let's decrease the speed a little bit. So when we make a new firework over here, when we say that the particle speed, we should change this from being between, yeah, let's change this to, the maximum will be 10 and the minimum will be 5. Okay. Okay, so now we have like this weird circle system going on, but it's not really circular because it always has like edges, which is super weird. And in fact, it shouldn't even be like this. It should be a straight up circle, so this is weird. It's also going, every firework is going really high. I don't like that. I want the fireworks to go a little bit lower down. So over here, let's say 1 divided by 20. Let's say 1 divided by 25. There you go. That's a larger division. That's super weird that they're not exploding in like a perfect circle. They really should be exploding in a perfect circle. Like that particle over there, why are you chilling out over there? Makes no sense. Like why are you behind any of the others? You should all have the same exact speed. Weird. I guess when we turn it into an int32, things get messed up. So to make things a little bit more precise, let's make all this stuff floats. Let's make like the pos x and pos y, all of that will be floats. I guess it's gonna have to be a float 64. And then we'll get rid of these casting systems over here. Pos x. You know what? The velocities could be. No. Yeah. Okay. Pos x and pos y. The int. Yeah. Okay. Let's make this float 64 of x. Float 64. We're just losing some precision when we turn it into integers. So I'll just turn them into integers when we draw them, but at all the other times I want everything to be precise. So let's do that. And then int 32. This probably doesn't matter actually because we're going to randomize the speeds. So whatever. So there you go. Now we have this perfect circle, which is much more pleasing if you ask me. Okay. So a few problems. A, the particles go off into infinity. And B, the circle is too perfect. So I kind of like the perfect circle a little bit. I'm not going to lie. You can decide whether or not you want to keep the perfect circle or not. For now, let's fix one problem at a time, which is let's make the particles disappear after a certain amount of time. The best way to do this, in my opinion, is actually to slowly twinkle them out. Like they'll slowly fade away. So every particle should have a new value, and we'll call this alpha. Alpha. This will be the colors alpha, which will be of type, I think, yeah, let's do this int32. And then whenever we make a new particle, the alpha will be set to 255, because it's a color value, really. And then when we update, we'll say that the p dot alpha minus equals, let's say 10 for now, and then p dot color dot a equals p dot alpha. The reason why I have to do it this way and we can't just slowly decrement p dot color dot a, which is the alpha value of the color, the reason why we have to do it this way is because the alpha color is actually a uint 8, which means it can't be negative. And I need to know when p dot alpha becomes negative. Because when p dot alpha becomes negative, we're going to actually remove the particle from the screen. So for now, we're just going to put it this way, and you'll see them slowly disappear. They will slowly disappear. The problem is they'll still be there. They'll just be hiding, which is a little bit annoying. So explosion, and you see how they actually twinkle like this, right? So the reason why they're doing that is because whenever the p dot alpha becomes negative, this thing messes up and it goes crazy. So what we'll do is we'll say, what we'll do is we'll say if p dot color dot a minus p dot alpha if yeah, okay, no, I'm sorry, I messed this up. If p dot alpha is greater than or equal to 0, then we want to do this. So only if the alpha is greater than or equal to 0, then we want to do this, and this will make them fully disappear. This is just uint8 stuff going on. So now they'll disappear and they won't come back. The problem is the particles are still there. Actually, you just can't see them. So we have to make a new function, p particle, and this will be called has fizzled, like has the particle fizzled, and this will return a boolean. And this will return p dot alpha is less than or equal to 0. If the alpha has gone below 0 or is 0, then the particle has fizzled out. And back in the game struct, we can say if g dot particles index I dot has fizzled, in our particle loop where we're updating the particle, we can say if it has fizzled, then we'll do a similar maneuver that we did with the fireworks. We'll say g dot particles index I equals g dot particles index length of g dot particles minus 1. So we're swapping the two things, and then we'll say g dot particles equals g dot particles equals g dot g dot particles equals g dot particles index everything up until the length of g dot particles minus 1. Shouldn't be there. Wait, what's going on here? Yeah, again, stop it with that. Okay. G dot particles equals g dot particles index everything up until the length of g dot particles minus 1. So in order to see if this is working, we're going to turn off the fact that they slowly disappear, just so that I know if they go away. So this is the stuff that makes it slowly disappear. And now I need to know if it goes away. Boom. Okay, yeah, it goes away. And boom. 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 Okay. So now they will slowly disappear. So I like this a lot. I kind of like the circle explosion, even though the way that I did it before didn't have the circle explosion. So what we're going to do actually is we're going to randomize it. Sometimes it will be a circle explosion, sometimes it won't be a circle explosion. And to do that, we're going to have to be a little creative. So what we'll do is we get this speed. We get this speed from the firework, and we'll say that, okay, we'll say we'll say var vel x comma vel y will both be float 64s. And then and then we'll say if our rand dot float, if we get a float 32 value, if that random float 32 value is greater than 0.5, this will be how we do val x and val y. Oh, actually, no, we can't do that. We can't do it this way, because now some part of, yeah, no, this is a bad way to do it. Sorry, I just realized that the way I was about to do it does not make sense. Let's back everything else up. How are we going to do this? Okay, let's change speed from being speed to being minimum speed and being maximum speed. So we're going to get two values. We're going to get the minimum speed that the particle could be, and we're going to get the maximum speed that the particle could be. And then we will say that the actual speed that the particle could be, we'll say if Okay, var speed float 64. This is pretty cool actually, because now we'll be able to get rid of this casting thing over here. The speed, the actual speed that the particle will be a float 64. And then we can say that if rand dot float 32 is greater than 0.5, then no, again, the randomness will not be done here. It's if the minimum speed equals the maximum speed. If the minimum and the maximum speed are the same, then speed equals float 64 of the minimum speed. Else, in other words, if we've been given that the minimum speed will be different than the maximum speed, then we'll say that the speed equals random dot float 64, and this will take in, what will this be? The maximum speed minus the minimum speed plus the minimum speed. And this will be, sorry, this all doesn't make sense. We have to do int 32 n, and also stop casting stuff. Yeah, stop casting. No casting. The only casting that will be done will be the final casting, float 32. Sorry, no, float 64. Casting all this to a float 64. So what is going on in here? Well, this is a great way to do a dynamic random function, which is basically, what do we want the range to be of our random thing? Well, we want it to be, let's say the minimum speed is 5 and the maximum speed is 10. Well, if the minimum speed is 5 and the maximum speed is 10, that means that the range that we're working with is 5. From 5 to 10 is 5. So conveniently, that is also the maximum speed. The range is the maximum speed minus the minimum speed. So we pass in the range over here, and then we just have to offset the range by the minimum value. So this will give us a value between 0 and 5. If we add the minimum speed, then we're basically getting a value between 5 and 10, which is what we want. We want it to be within the range of 5 and 10. So great. But now we have to, so now that we're getting it like this so that it's randomized, it's not yet randomized. Now we have to go into the Firework struct, and whenever we make a new particle over here, we will say that, yeah, we'll have two different loops. One of the loops will be if we want it to be a circle explosion, and one of the loops will be if we want it to be a normal, a random, like, blah, blah, blah explosion. To do this, we will say that, yeah, if rand dot float 32 is greater than 0.5, then just do things like this, and the minimum speed will be f dot particle speed, and the maximum speed will be f dot particle speed. So now we're passing in the same value for each of them. Else, we'll have a very similar for loop. So whenever we get the particles, we're going to see if we want to have a circular explosion or a, let's call this chaotic explosion. Okay. So this will be the circular explosion, this will be the chaotic explosion. And then we'll say for I equals the range of new particles index I equals new particle, and instead of having it like this, we'll say f dot particle speed, let's say minus, what is the particle speed? The particle speed is between 5 and 10. So this will be particle speed minus, let's say, 3, and then the maximum could be particle speed plus 3. So that it will be, so we're just spacing things out a little bit from the given particle speed so that we'll have some randomization. Okay, let's run this now. This should work, I believe. Okay, so that was chaotic. That's circular, 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 circular. I believe these are all circular. Chaotic. That's a chaotic. The chaotic. There you go. Circular, circular, chaotic, circular. Okay. I think this is pretty good. Maybe it should be that. Yeah. Maybe we should make it so that if it's chaotic, things are just smaller. So instead of it being -3, we'll make it like the particle speed minus. It can't be -5 because then we could end up in a situation where we're giving it. Actually, maybe it could be -5. Maybe it could be -5 actually. How are we doing this? This is the minimum. The minimum, I guess the minimum could be 0. So let's do particle speed -5 up until the normal particle speed. And for now, let's make it so that we never get a circular explosion, just to test out our chaotic explosions. Just to test out our chaotic explosions. Let's do it this way. So how would we do that? Well, we would say that if it's greater than 1, which it will never be greater than 1. So now we'll only get chaotic explosions. Chaotic explosions. Okay, I think the chaotic explosions look pretty good. One thing we might want to do is we might want to increase the radius of our particles. So the particle radius, when we make the particle radius, instead of it being 1, let's make it like 2. So it'll be twice as big. There you go. Okay, I like that. Yeah, that's pretty cool. I'm a fan. I like these explosions. Good. I don't like the idea that sometimes the particle speed will be 0. But I think it's okay. I really do. Alright, so 0.5. Great, now let's check out what we have so far. So circular, chaotic. I like the chaotic ones actually, but the circular ones are cool too. I'm honestly I like these explosions. These explosions are pretty cool. Really am a fan. Perfectly honest with you. Okay, one thing that we should do. So we're almost done, by the way. Now we have like the basic explosion done. One thing that we should do is we should see if there's a way to if there's a way to make a general function for generating particles. I mean generating fireworks. No, this is okay. I think this is okay. Yeah, let's actually no, I don't like it. Let's make a function. Func G star game, and we'll call this make firework. You'll see why I want to do this. Actually, you know what? We don't need to do this now. We don't need to do this now. We will simply add sound. It's time to add sound. Okay, how do we add sound in Golang? Well, the first thing we need is some sounds. So I've actually made this very easy. I believe that if you go to the description of the stream, which I'm going to check right now just to make sure that I've actually done this. Yeah, the link to the sound effects, I provided a link to the sound effects, which is a Google Drive folder in my Google Drive. So just go to the link and copy that description. I mean, go to the description, go to the link. Go to the description and copy that link. You'll be sent to a folder. These are a bunch of sound effects. One of them is like this explosion. There, that's an explosion. That's a firework explosion. So let's download this folder. How do you download folders? Over here. Download. Excellent. Okay, now that I've downloaded it, I'm going to open up a file. Go to my downloads, and I only downloaded one file. That's weird. Delete. I don't want just one file. I want the whole folder. Yeah, I only downloaded one file. I want the entire thing. Can I have the entire thing, please? Excuse me. Can I do this? Guys folder, access. Kind of want to download. Oh, I could just select all of them, maybe. Yep, download. Zipping 8 files. Yeah, okay, so yeah, so let's select all of them and then just download them. And it will come in a zip, which is great. So downloads, here's my zip. Now open up in another Finder tab or another File Explorer tab your directory to the project. So let's go to my project. So this is going to be in Alicia Schmallow, tutorials, firework simulation, code. Great, and I'm going to drag and drop this into here. Great. All right, now I'm going to expand all of this, extract all of it, and I'll extract all of it. Yeah, I'll just extract it into that. Sure. Okay. So now we can get rid of the zipped folder. Let's go in here, and we have all of these things, which is pretty cool. So let's rename this folder a little bit, because this is a big name. So let's just rename it. I'm going to go to Properties. This is how you rename stuff in Windows, Properties, and we'll call this SFX for sound effects. Okay. Great, that's all we need to do here. So now, back in Visual Studio Code, you see that we have all these things: an explode 1, an explode 2, an explode 3, an explode 4, a lift 1, a lift 2, a lift 3, a lift 4. The lift is short for lift off. So to load in, let's load in these audio files. To load them in, we have to go to our game. And the first thing we need to do is when we say rl.init window, let's do something similar, rl.init audio device. And then in the close function for our game thing, we'll do rl.close audio device. Great. Right after we initialize the audio device, let's make a list of all our liftoff sounds. So let's say let's just declare that we're going to make these slices. So lift sounds will be a list of rl.sound. And then explode sounds is also going to be a list of rl.sound. It's just going to be a different kind of list, or a different kind of sound, really. It's the same kind of list. So then we'll say g.liftSounds equals a slice of rl.sound, and let's populate this. So we'll say rl.loadSound, quote, and this is the file path, which is going to be sfx/explode1. Oh no, this is the lift sounds, so it's going to be sfx.lift1. These are MP3s, MP3, comma, and we have 1, 2, 3. There you go, 1, 2, 3, 4. So the next one's going to be lift 2.mp3, lift 3.mp3, lift 4.mp3. Great. And let's do a very similar thing, but instead of it being g.liftSounds, it will be g.explodeSounds, and instead of it being lift1, it will be explode1. See, I named things very, very uniformly. So obviously, we want to play the lift-off ones whenever we create a firework and it lifts off, and we want to play the explode ones whenever we explode a firework. So let's do that. Let's set that up. So where do we make the fireworks? Right over here. Whenever the mouse button is clicked, we make the fireworks. So right before we make the firework, or right after, it doesn't matter, we'll do rl.play_sound, and we're going to get a random liftoff sound. So we're going to say g.liftSounds index. How do we get random things from a slice? We do rand dot int 32n, because of the range, and this will be the length of g.liftSounds. But there's an error over here. We have to cast this to an int 32. Great. And now we should play a random lift sound whenever we lift off. Let's check it out. There you go. There's a random lift sound. Now it's a little bit weird when it lifts off and you don't actually hear it explode. That is a little bit trippy. So now let's add the explosion sounds. So we're gonna where do we explode things? Right over here. When we say g.fireworks dot should explode, we'll say we will say actually, you know what? Instead of playing the sound over here, we'll play the sound. Well, no, let's play it over here. It makes sense to play it over here. And then when we explode it, if g.fireworks that should explode, the first thing we should do is we should play the sound. rl.play sound, and this will be g.explodeSounds index rand dot int 31n, the length of g.explodeSounds, And then this also needs to be cast to a, the length needs to be cast to an int32. Okay, and now we should get a random exploding sound every time. Wait. Something's wrong. Oh, one of the exploding sounds is wrong. Which one is that? It's probably explode 4. Yeah, this has a liftoff sound in it. Okay, I thought I fixed that. That's really weird. Okay, I'm gonna delete this from the folder. Sorry if you're watching the live stream. No one's watching the live stream, so this doesn't mess anybody up. But what I'm gonna do is I'm gonna go into my other one, which is this. No, it's over here. Firework display. This is the original one that I made. Here are the sound effects. Here is explode 4. Let's play it. Yeah, I fixed it. I fixed it over here. I just forgot to bring it back into the Google Drive. So let's put it over here. Great. So now the explode 4 is in the Google Drive. Excellent. And then of course I also have to bring this new explode 4 into my current directory. So sound effects. Sorry, this is just stuff that I'm gonna have to fix. You shouldn't have to fix this because I just updated the Google Drive. Replace the file. Great. And this should work now. So in order to test this, I will come over here, and when we play the exploding sound, I won't get a random one. I'll get a very specific one. I will get the 4th one, which is index 3. So let's try this out. There you go. Okay. Sorry, I don't want to comment that out. Alright, one more thing. Not one more thing. There's a few more things. But another thing that we need to fix, or at least we should fix, is the fact that all these fireworks are going the same height. Which is honestly it's a little bit boring. It's a little bit boring. I'm not gonna lie. So what we want to do is we want to make it that I think we found a pretty nice area, like a pretty nice line across the sky, that this should be like the average height that the fireworks fly to. Maybe a little bit higher. Should be the average height that the fireworks fly to. So let's make it that the average height will be a little bit higher. In the firework file, the velocity should be divided by, let's say, 22. So that now they'll go a little bit higher. It's going to be a height divided by 22. Okay, so there you go. This will be the average val. Let's call it. You know what? Let's keep it as variables. So this will be avg val. And then what we want to do is we want to say that the actual velocity, and you know what, this will be the avg speed, because for now I don't want the negative value. And then the velocity will equal random dot int 31n, but this I want it to be negative, of course. I want to just switch this to negative. And if this is going to be the average, then we could simply do maximum minus minimum again plus minimum. And so now we can make like a nice range across. So we could say speed range colon equals, let's say, I don't know, 5. No, 10. 10, sure. And then we'll say that the maximum will be avg speed plus 10 minus avg speed minus 10. Good. So this is the maximum value, and this is the minimum value to get the range that we want, and then we'll just add avg speed minus 10. All right, let's run that. Oh, something went wrong. Oh, sorry, 10. I hard-coded 10 in when I made this variable to use instead. What's wrong here? I guess this is starting off not as an int32, so let's change this to var speed range int32 equals 10. Excellent. Now we should be getting random heights for each one of these fireworks. Oh, that's weird. How about, yeah, this is the problem. It needs to be minus It needs to be minus all of this. Because the average speed is actually a negative value. Like the speed that we want is actually needs to be a negative value. Wow, they're going really high. Some of them go really high. Some of them go a little bit too high. Let's make the average a little bit lower, as it was before. Yeah, okay. Yeah, okay, so now the maximum is pretty high up, and the minimum is pretty low down, and I like this. I like this, no, let's make the range a little bit less, shall we? There you go. The range could be... Actually, no, now the range is 10. Now the range is 10, because this one's going up by 10, and this one's going down by 10. Okay, so, yeah, you know what? I made a big mistake, so let's make this 22 again. That was just me messing up. All the values were right in my head, it's just I messed up. Some basic intuition. Okay, I like this randomization. Good stuff, good stuff. Alright, now we get to do the fun thing, which is set up the system that will allow us to make a firework display. So let's do that. First of all, I'm going to collapse this. And then, on the game, we're going to have a new value, and it will be called display on. And this will also be a Boolean. And we'll come down to the loop, and we'll say, yeah, right after we check if the window should close, we'll say if rl dot is key pressed, and this will be rl dot key space. So if the key space is pressed, then we'll say g dot display on equals not g dot display on. So this will toggle the display essentially. If the display is on, it will turn it off. If the display is off, it will turn it on. And then in the update, we can say if g dot display on. Now what I want to do is I actually want to make sorry, this is not supposed to be a function. Then I actually want to say g dot create firework. And yeah, okay, so I'm gonna come. I don't know. Let's just make one. I don't know where we'll put the function. Let's just put the function right over here. Why not? Func g star game create firework. Great. All right. The reason why I want to do this is because we have this code over here for creating the fireworks that has 2 lines in it. That I don't, if I want to change one of them, I don't want to have to change both of them in both places. So I'm just going to copy this line over here. I'm going to put it right over here. That we play the sound and then we make this new firework. And we'll pass in the x, which will be of type int32. And instead of hard coding in that it will be the mouse x position, we'll actually pass in the x over here. And then up here, we'll say whenever we click the mouse button, we want the game to create a firework at rl.get mouse x. But then if the display is on, we want the x to be random. So we want this to be rand.int31n between 0 and the width of the screen. Oh, did I misspell width? I misspelled width at the beginning of the stream. Width. Okay, and then I actually have to fix that over here as well. Yeah, when we make the window. Great. Okay, so now, yeah, this should work. If the display is on, we're going to make a firework with an x position between 0 and the width. Let's run this. So it's working normally. And now, if we press... Oh, I messed up. This is going to be crazy. It's like D-Day. So... It's a lot of fireworks. That's actually really cool. If this is too many fireworks for you, because this is making 60 fireworks a second, let's just be clear about that. If this is too much, then we can say if rand.float32, if 0.5 is greater than rand float32, then we'll create the firework. If 0.5 is greater, so now this is a point. If 0.1 is greater than the rand, no, No, sorry, hold on. I don't want that. I don't know why I put it that way. If the random float is greater than 0.5, then I want to create a firework. So this will be only half of the time do we create fireworks, and this will be a little bit less. But honestly, it's still quite a lot. It still is quite a lot. So let's make this a little bit less. This will be like, no, wait, hold on. Hold on, yeah, this needs to be a less than sign. This will be a 10% chance. So now we have this value is like the 10. This is 1/10. So a 10% chance of making fireworks. Now we have a 10% chance. Let's see. So this is going to be, yeah, pretty not so many fireworks. A fair amount. So you could tweak this value over here whenever you want. Let's come over here, make this into a constant. Display, I don't know. You know what? Let's first of all capitalize this differently. Display firework. Oh, actually, you know what? I'll do firework display. Firework display rate equals. Let's do 0.1 again for 10%, and then we'll come back to the game and we'll do firework display rate, and then this should be the same thing except now it's a constant that you could tweak and stuff. Again, just to remind you that it was before. What it was before was 90. Let's do 100%. So then now we are always making fireworks now. So this is what that looked like. Wow, that is a lot of fireworks. Just to be clear, that in Python, I don't think that you could do this. But let's just see if we're losing the frame rate. So let's fmt.println rl.get FPS. Let's get the FPS that we're on to see if we're losing any frame rate when we turn on the display. So right now we're at a nice 59 FPS, which is 60, which is what we wanted. And yet we're not losing any frame rate. In Python, you would lose frame rate. At this point, you would be losing frame rate in Python, I believe. The way we've started things. So this is pretty cool. Another example of Golang just being a little bit faster than Python, which I like. Which is why I like Golang, because I used to code in Python. Now, by the way, I'm sorry if there's an echo with the sound, because it's coming out of my computer and into my microphone, so whatever. What else did I want to do? Right, let's make a functionality so that you could use the arrow keys to increase the rate and decrease the rate when the display is on. So let's come in the let's do it over here. If rl dot get, let's do get key pressed, and this will be, no, if rl dot is key down, rl dot key up. So if the up key is pressed, then we'll say that the display that ooh, shoot, because we made display rate a constant, didn't we? Yeah, so let's change that. Let's come over here. We'll get the firework display rate, and we'll actually make this a game value. Firework display rate, which will be of type float 32. Why not? And then in the game, when we initialize the game, we'll say, oh, first of all, we should say g.display. Sorry, not f.display. G.display on equals false, and we'll say g.firework display rate equals 0.5. And now we can actually modify it, which will be good. So we'll come over here. If the up key is pressed, we'll say g.firework display rate equals math.min. Oh no, this takes in like the min 30. If the key is up, then firework display rate plus equals 0.01, so 1/10%. Sorry, 1%. So then there's 1% greater chance. And then we'll say if g.firework display rate is greater than 1, we'll simply set g.firework display rate to equal 1. so that the display rate never goes above 1, essentially. What's the error? What's wrong? Oh, this needs to be g.firework display right now. G.firework display rate. Great. And now let's do the opposite if key down is being pressed. So key down minus equals that. If it's less than 0, then it should equal 0. Okay, let's try this out. Alright. So now this is a display, and let's just very few fireworks. Now there's some, now there's a nice amount of fireworks. Let's bump it up a little bit. Yeah, all the way up. Very cool. And this should be like all the time fireworks. Bump it down, a little bit down, a little bit less, a little bit less. Nice amount of fireworks now. Oh, there's a nice amount. Okay. Okay, so that's it. There you go. There's all the code. Now, what you could do, which is awesome, I think I haven't tried this yet, because there might be some issues with like the sound effects and whatnot. But let's see. Go build everything. Let's build this into an executable. There you go. So now we have code.exe. You can bring this into your desktop. Let me minimize this, move it over, and also move over Google Chrome. You could bring, oh shoot, I don't think I can bring it from VS Code. Let's see, where would this be? Right, tutorials, Firework, simulation code, and we have this code.exe file. You could bring it to wherever you want, and you could run it. And now, as you see, we have this. The sound isn't working. Interesting. Not sure what you would need to do to get the sound to work. We can actually find that out right now. Add files to Go build. It's probably what you need to do. How to compile Go program consisting of multiple files. They're going to say go and what? Supposing you're writing a program called myprog, put all your files in a directory like this. My project go source, yeah. Okay, go and run go, and that way you'll be able to add other packages and programs to if you want. I don't think this is what we're looking for. Let's just see. Go install. And this needs to be like code. What? No. Cannot find package code in it. Yeah, okay, fine. Yeah, no. I don't think this is what we want. Yeah, I don't think this is what we want. We want like the go build. Oh, let's type this in. Go build. By the way, if you don't care about executing if you don't care about building the executable, then we're done. Just by the way, you could run it, and very cool stuff, up and down. Congratulations on the video. If you want to stay tuned to finish up the building process, then stay tuned. We're gonna figure that out right now. So go build -help. Is it -help or is it just help? I think it's just help. No, wait. Just go help. Just go build help. Go build help. Help. Cannot find package help. Go help build. There we go. Go help build. All right. All right. Let's start reading. Usage go build, output, build flags, packages, build compiles the packages named by the import path along with their dependencies, but it does not install the results. If the arguments to build are listed of the good.grow from a single directory, build treats them as a list of source files, specifying when compiling packages, build ignores files that end in okay. When compiling a single main package, build writes the resulting executables to an output file named after the first source file. Okay, so there you go. Right, okay, very good. Yeah. When compiling multiple the O flag forces build to write the resulting executable or to the named output file or directory instead of the default behavior described. No, I don't care about that. The -I flag installs the packages that are, no, we don't care about that. The build flags are shared by build, clean, get, installed, okay. -A, forced rebuilding of packages that are already up to date, no. -N, print, no. dash P space N, the number of programs such as build or no, that's not what we want. This probably is not what we want. Dash race dash M san enable interoperation with memories. No, we don't want that. A san enable, no, we don't want that. Dash V print the names of packages as they're compiled. No. Dash work print the name of the temporary work directory. No. Dash X print commands. Dash ASM flags. Pattern args list arguments to be passed on each tool ASM invocation. I think we might want this. I don't know. Build mode to use. C go help build mode for more. Build v okay. Compiler name. GCC no. GC flags. Install suffix no. No. Link shared no. Mod mode no. No. Mod file no. Overlay file probably not. Package directory, install and load all packages from directory instead of the usual, no. Tag list, a comma separated list of build tags to consider satisfied during the build, no. Trim path tool exec. You know what I bet? I bet that if we put the executable file back into our directory, then it will work with the sound effects. Yeah, it works with the sound effects because it has to find the sound effects in the file, and the file, it needs to be in the same directory. So you would have to export these two like in the same zip file. I wonder if there's a way to not have to do that. That's the question. Tool use. Let's type this in. How add assets to go build. I guess this might make sense. This might pop up with something. Embedding assets in Go. Let's see. Remember, Go is not really a game development language for most people, so there's not a lot of a documentation. Make their assets install sh. I don't know. Yeah, I don't know. So yeah, I don't know how to do this. If you want to research it, you totally can. How long have we been going? An hour and a half. That's pretty good. I don't know how to fix that. So, in short, we finished. If you want to export this to your friends, just remember to like zip it up with the sound effects. So for example, a full game would look like this. So I could, not game, but I can come to my desktop and I can say that we should make a new folder. No, I don't. No, I can't. Let's just, yeah. So let's go to the desktop and new folder. I can call this Fireworks display. And then in the Fireworks display, we can paste the sound effects and the executable. And then you can like zip up this folder and send it to your friends, and they can open it. And if they run the executable, then they'll get the sound effects, and you can turn on the display, and everything works. Okay, so that is it for everything. I'm just gonna delete this. Yeah, I'm just gonna delete that. Deleting. Yeah, great. I think that's it for the code. Let me just decrease the audio so that I can talk while stuff runs. Nope, I want to run. There you go. That's it for today's tutorial. I hope you guys enjoyed. Leave a like if you did. Comment any questions or concerns below. I'll respond to all of them, I promise. Unless this is like 30 years into the future and I'm dead or something. I hope I'm not dead. Anyway, if I see it, I definitely will respond to it. I'll help out, especially like within the next few weeks. There's not going to be a lot of comments anyway. The comments will definitely get noticed. So comment if you like, any suggestions, what have you, but especially if you have any problems, let me know. I'll help out. Someone else in the comments might help out. Leave a like if you enjoyed. Thank you all for 200 subscribers. That's great. We'll continue the NNFS series tomorrow. Again, check out my channel for that playlist and other Go tutorials as well. Well, there isn't that many as of now, but I hope to have a lot of fun making. Yeah, so I think that's pretty much it. Sorry, I'm just enjoying the display. Yeah, okay. I think I'm gonna end the stream. I don't think there's anything else. Good. It's been good chilling with you guys. I hope you guys had a good time, and you made something cool today. And honestly, it really is kind of cool. Oh wait, there's one more thing that I forgot to do. Yeah, I forgot to make it so that the white fireworks explode into multicolors. Let's do that now. Shoot, my bad. Let's just do that. When the firework explodes, when we get new particles, this is annoying because now we have to do it both if for the circular and for the chaotic. But if firework.color does not equal white, or if it is white but it doesn't but there'll be a random or rand dot int 31n or rand dot float 32 is greater than 0.5 or actually less than. So now there'll be 50% of all all the non-white fireworks will send a normal explosion, and 50% of the white fireworks will also just send their explosion as white. Otherwise, we want to do this exact same thing, but the color, but in the for loop, C : equals particle. No, sorry, it's firework colors. Firework colors index rand dot int n31 length of firework colors -1 int 32 of that. Great. This will get us a random color, and then instead of being f.color, we'll pass in C over here. And we'll do that over here. And then this needs to be inside the for loops because every particle needs its own color. Great. Now, let's see if this works. We need to get a white firework here. Okay, what I could do is I could go to the game, and whenever we make a firework, it is simply going to be, sorry, I need to go to the fireworks, and every time we make a firework, the color will be rl.white. So now the only fireworks will be white. Yeah, I guess we could comment this out. Let's run it. Let's turn on the display or something. Now, yeah, some of them are rainbow. 50% of them are rainbow. Rainbow. Great. Alright, so sorry that I forgot to do that up until now, but there you go. It's done. That's it. Everything else is that's all there is. Comments, questions, concerns, everything down below. Like the video if you enjoyed it, and recommend it to, I don't know, your friends if you want to get, like, just, I don't know, whatever. Whatever you want. Great, now they're rainbow. Excellent. Good stuff. Hope you guys have a great night or day or whatever, and I'll see you guys in the next video. I'm going to end the stream. Bye.